In this section, we are going to continue solving quadratic equations using the quadratic formula. In lesson number 1, we learned what the quadratic formula was, and one of the most critical things before you can use the quadratic formula is what I'm highlighting in yellow at this current moment, is that in order to use the quadratic formula, the quadratic equation must be in standard form, which is ax squared plus bx plus c is equal to 0. Then you can carefully use the quadratic formula. So let's go ahead and go into the next couple of questions here. So here in this particular question, what you'll notice initially right away is that this is not in standard form. We do not have the squared term first, the x term second, the constant term third, and it doesn't equal 0. So the first thing we'll want to do is make one side equal 0. In order for me to do that, I'm going to subtract 3x and add 4. So at this point we have the left side equaling 0. And now we have standard form. We have 0 is equal to the squared term, the x term, and the constant term. So in this case, a is equal to 1, because the coefficient there is 1. Okay, b is equivalent to -3. And c is equivalent to +4. And as you saw in the previous lesson, there are 3 products that are important to calculate before you do the quadratic formula. So the product b squared, the product 4ac, and the product 2a. So b squared is -3 squared. 4ac would be 4 times a, which is 1, times c, which is 4. And 2a would be equivalent to 2 times a, which is 1. So in this case, these 3 products, first one would be 9. The second one would be 16, and the third one would be 2. So if we go ahead and start solving this using the quadratic formula, so let's go ahead and start substituting. We will have x is equal to negative b, which is -3, because b is -3, plus or minus the square root of b squared, which is 9, minus 4ac, which is 16, all over the product 2a, which is 2. So in this case, the next thing to simplify is 9 minus 16. So we have x is equal to 3, because -3 is 3, plus or minus the square root of -7, 9 minus 16 is -7, all over 2. Now if we look at the graph, as we noted in the last lesson, is that the solutions are actually the x-intercepts, the zeros. So if you look at the graph of this function, I just graphed the function x squared minus 3x plus 4. So the standard form, I graphed x squared minus 3x plus 4, and what you'll notice when I hit graph is that there are absolutely no x-intercepts. So there's actually no solutions to this particular question. The way we can identify that using the quadratic formula is actually at this point. What you'll notice is there's a -7 in your square root, and you cannot square root a negative number. So the way to identify using the quadratic formula that there's no solutions is if you have a negative number under the square root sign. If you look at my calculator, if I try to square root -7, it will give me an error, because nothing times itself can be -7. So in this case, what you can assume here is because you can't square root a negative, that means that there's no solution. Okay, let's go ahead and start the last question. What you'll notice in this last question is that although one side equals 0, it is not in standard form. The standard form has the squared term first, so this squared term has to come first, the x term second, which is plus 23x, and the constant term third. Now in this case, because there's no constant term, your constant term is 0. Okay, so let's go ahead and start using the quadratic formula with a little bit less guidance. But what we know is that a is equal to -8, so that's a. B is equal to 23, and c is equal to 0. So I would approach this the exact same way. I would go ahead and start finding out the 3 products. I would find out what the product b squared is, what the product 4ac is, and what the product 2a is. Those are the 3 products in the initial quadratic formula. So b squared would be 23 squared, 4ac would be 4 times negative 8 times 0, and 2a would be 2 times negative 8. So those three products would be 529, 0, and negative 16. So if I go ahead and substitute those into the quadratic formula, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, here's where I'm substituting those values. Okay, so my quadratic formula at the moment looks like x is equal to negative b, which is negative 23, plus or minus the square root of b squared, which is 529, minus 0, all over negative 16. Okay, so this gives us x is equal to negative 23 plus or minus the square root of 529 all over negative 16. And then I could just take the square root of 529. So square root of 529 is 23. So in this case, we have x is equal to negative 23 plus or minus 23 all over negative 16. Now again, what we're going to want to look at is the two cases. We've got a negative and a positive case. So let me go ahead and show you those two cases. So the positive case, we have x is equal to negative 23 plus 23 all over negative 16. And the negative or minus case, we have x is equal to negative 23 minus 23 all over negative 16. So if you look at the numerator of the red case, negative 23 plus 23 is 0, and 0 divided by negative 16 is 0. That's one of our solutions. And our other solution, if you look at the orange numerator, would be negative 46 over negative 16. And on my calculator, if I do negative 46 divided by negative 16, I get 2.88. So on my graphing calculator, if I would like to go ahead and justify or find this out, what I would do is put in the function in standard form. So the function in standard form was negative 8x squared plus 23x, negative 8x squared plus 23x plus 0 if I'd like to, and go ahead and graph it. What you'll notice is my x-intercepts are at 0, which is one of my solutions, and at 2.88, and you could actually calculate those if you would like to. So your solutions here are 0 and 2.88. Okay. Now, if you're in my class, what I would like you to do is go ahead and try the next question and get myself to initial it. Okay, and that is solving using the quadratic formula.